Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of sequence and series. And if I talk about the question that is given to us here, the question tells me let ABC be an equilateral triangle and a new triangle is always formed by joining the midpoints of all the sides of the triangle ABC. So you have to always form a new triangle by joining all the midpoints of the triangle ABC, and that same process is repeated infinite times. The question says that if P is sum of the perimeters of all the infinite triangles which are formed, so P is sum of perimeters and Q is the sum of all the areas of all the triangles that are formed there. We have to figure out the relation between P and Q, and the answer choices give us the relation. One relation is P square is 72 root 3Q. B says P square is 36 root 3Q. C says P is 36 root 3Q square. And the D answer choice says P square is 6 root 3Q. So let's figure out which one of the answer choices is the correct answer for this question that is given to us here. One thing we know for sure that sum of perimeters is just any unit, but the area has its unit as unit square, right? So if both the sides have to be equal, I cannot have q square because it will become, let's say if it is meter square, it will become meter square square, which is meter raised to 4. But the left hand side is just in meters, which is not a correct thing. So C is definitely not correct. C is out of the answer choices. So now we have to just figure out of A, B, and D, which is the correct answer choice. So if I first draw a triangle equilateral, which is ABC. Let's say the measure of each side of the equilateral triangle is A. Now in that I have to form infinite triangles by joining the midpoints of these triangles. So if I join the midpoint of these triangles first, this divides it into the ratio of A over 2, A over 2, A over 2. So it basically becomes half of A. So if I draw a triangle now, the new triangle, let's name it as DEF. So this has the sides length as A over 2. So everything is A over 2. Again, if I join this midpoints and form another triangle, let's say XYZ, this will have the side measure A over 4. So on, it will basically become A over 8, then A over 16, and so on. Infinitely, we have to draw many triangles as possible. Now, P shows me the sum of perimeters of the triangles. So perimeters, we know that perimeter is nothing but sum of all the sides in the triangle. So for the first triangle, if I find the perimeter, it's A plus A plus A, so which is 3A. Then if I find the perimeter of the second triangle, which is inside the first, it is A over 2 plus A over 2 plus A over 2, which is 3A over 2. If I find the perimeter of the third triangle, it's A over 4 plus A over 4 plus A over 4, which is 3A over 4. Then inside, if I find the perimeter of another triangle, it's A over 8 plus A over 8 plus A over 8. So that's 3A over 8. So what I understand is from this question, I can just add all the perimeters that are present. So 3A plus 3A over 2 plus 3A over 4 plus 3A over 8 plus 3A over 16 and so on. So I'll keep on adding them. Now once I see, I can figure out some things are common here. So if I take the common things, I have 3A common. So I'm left with 1 plus half plus 1/4 plus 1 over 8 plus 1 over 16 and so on. Now, what if I see here is if I want to find the sum of these terms, which are going till infinite terms, if I see the sequence, that sequence is basically in geometric progression. And how do I understand that? Because there is a common ratio between the consecutive terms. So if I divide this, half over 1 is half, then 1 over 4 divided by half is also half. So basically to get every next term, I am multiplying my previous term with half. So my common ratio, which is constant, is half here. Now once I have that common ratio, which is half, I can just use the idea of sum of infinite terms in a geometric progression, which is a over 1 minus r. So that leaves me with p's value becoming 3a times a is my first term, which is 1 over 1 minus the common ratio, which is half. So I get 3a over half. That basically makes it 2 times 3a, which is 6a. So perimeter of all the triangles that I can form, that infinite triangles, is 6a. And if I find the sum of all the areas, so Q is A1 plus A2 plus A3 plus A4 and so on. So let's try to find the sum of all the areas of this infinite triangles that I can form. So for the first triangle, if I know the equilateral triangle's area is given by root 3 by 4 times side square, which is A square. So it becomes root 3 over 4A square as it is. So here I get root 3 over 4A square. The second area, if I find out the side's length was A over 2. So it basically becomes root 3 over 4 times A square over 4. So root 3 over 4 times A square over 4. The third area, I get root 3 over 4 times. It basically becomes A over 4 squared. So root 3 over 4 times A square over 16. Then I get a over 8 squared, which will become root 3 over 4 times a square over 64, and so on. This also goes to infinite terms. So from here, if I see, I get root 3 over 4 times a square. Everything is common. So the left out terms are 1 plus 1 over 4 plus 1 over 16 plus 1 over 64 till infinity. So you get root 3 over 4 times a square. And this basically, if you see, it's a geometric progression which has a common ratio which is constant. So every other term, if I want to figure out, I have to just multiply with 1 over 4. So here I get this answer becoming a over 1 minus r. So 1, which is my first term, over 1 minus r. So 1 minus 1/4. So from here I get root 3 over 4 times a square times 1 over 1 minus 1/4 is 3/4. So from here I get this is root 3 over 4a square times 4 over 3. So 4 and 4 cancels. You just get root 3a square over 3. So I get the sum of all the areas of this infinite triangles that I can form here. And that is root 3 over 3a square. So that's my Q. Now, if I see here, the question says to me that you find p square and you find and multiply with q. So let's first find p square directly. So if I find p square, I know p is 6a, so p square will become 36a. 6a the whole square, so 36a squared, right? And now if I have p square is 36a squared, and from q, if I try to figure out a square, I can just put it 3q over root 3 is a square. So instead of a square, I'll just put 3q over root 3. So 3, I can split it as root 3 times root 3, q over root 3. This and this cancels, I get p square is 36 root 3q. So if I see that basically matches with answer choice B. So B becomes the correct answer for this question that was given to us here. I hope you have understood how to solve this type of questions. So we first figured out the sum of perimeters of the infinite triangles I was able to form. When I took some things out common, I found it a geometric progression. So I just applied the idea of sum of infinite terms for a geometric progression. That gave me the sum of perimeters as 6a. Then I figured out some of the areas of all the equilateral triangles that I can form. Again, it was having a geometric progression inside the bracket with uncommon terms. So I have again applied the idea of sum of infinite terms, and that led me to q becoming root 3 over 3a square. Then I just found out the relation between p square and q, and that basically matches with answer choice B. So B becomes the correct answer here. I hope you have understood how to solve this question. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well, and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions that we are solving. Thank you.